Hello. In this video, we present the synthesis of carbon-11 labeled Perampanel, a useful radiotracer in nuclear medicine using positron emission tomography for epilepsy research. In general, the synthesis involves the sequential attachment of aromatic rings to a bromopyridone core structure. This is achieved through a series of coupling reactions using commercially available starting materials. In the final step of the synthesis, carbon-11 is incorporated into its nitrile group. Given the short half-life of carbon-11, which is approximately 20 minutes, it is therefore considered most practical and convenient to incorporate it during the very last step of the synthesis, as we will see later. Preparation of bromopyridone. The regioselective bromination of 2-methoxypyridine with molecular bromine yields bromomethoxypyridine 2. The treatment with hydrochloric acid, carried out under reflux conditions, generates bromopyridone 3. Preparation of 2-bromopyridine. Regioselective metallation of pyridine utilizing the complex formed with N-butyllithium, and then, through a subsequent reaction with tetrabromomethanes, ultimately yields 2-bromopyridine 5. Preparation of the dye-substituted bromopyridone intermediate. Substitution of bromine in compound 3 in order to generate a derivative of boronic acid 7 is carried out through a reaction with B-deoxyborylane 6. This reaction occurs in the presence of palladium-2, which functions as a catalyst, leading to the formation of compound 7. Following this step, through a Suzuki coupling reaction, which involves derivative 7 and the compound 5, is then carried out. This particular transformation is catalyzed by palladium-0. This reaction leads to the formation of pyridone 8. N-arylation of pyridone 8 through the Ullmann reaction utilizing phenylboronic acid 9 and catalyzed by copper salts produces the desired N-phenylpyridone 10. The bromination of compound 10 with N-bromosuccinimide is used to generate bromopyridone 11, preparation of 2-bromophenylboronic acid. The regioselective bromination of bromobenzene 12 with the reagents shown produces orthodibromobenzen 13. The bromolithium exchange between dibromobenzene 13 and N-butyllithium, followed by a reaction with trimethyl borate and subsequent acid hydrolysis, yields bromoboronic acid 14. Final steps of the synthesis. The Suzuki-type cross-coupling between bromopyridone 11 and boronic acid 14, catalyzed by palladium, leads to the incorporation of the bromophenyl group to the pyridone ring structure. This reaction yields intermediate 15. To incorporate the carbon-11 labeled cyano group through the substitution of bromine in compound 15, the initial step involves replacing the bromine atom with a dioxyborylane group. This is achieved by allowing the brominated compound 15 to react with B-dioxyborylane 6 in the presence of palladium for the purpose of preparing intermediate 16. The reaction of intermediate 16 with potassium cyanide, which has been labeled with carbon-11, is the final step of the synthesis. It is important to highlight that in a previous presentation, which was referenced here, more information is provided regarding the preparation of hydrocyanic acid labeled with this particular isotope. The incorporation of the radioisotope is catalyzed by copper-1, utilizing a diamine as its ligand in order to ultimately generate the desired labeled drug. In summary, here are the main raw materials and their structural contribution. Thank you for your attention.